welcome back to another video in this week's Java data structure tutorial. So in this video, like I promised, we have a new data structure that we're going to be talking about, also known as heaps. So heaps, I mentioned this once very briefly, maybe 3 or 4 weeks ago, so you probably don't remember, but it is a new type of heap, a new type of data structure that we are going to be learning in accordance to one of our previous data structures. So this is kind of looping together quite a bit of stuff. So heaps are the legitimate data structure name. That is the actual data structure. However, in Java, we don't have anything called a heap. So there's no such thing as a heap in Java. What we do is we use the priority queue to implement a heap. So I'm going to let you take that in. We talked about queues, I think in week 3, which was 3-4 weeks ago. And for queues, we at the time did not use priority queues, but we did talk about the different types of queues. And one queue we mentioned was the priority queue. So now it's time for us to put that into use. We're going to be using the priority queue basically to kind of copy a heap. So it's like the same idea essentially, but since heaps don't exist in Java, we can only stick with priority queue. So in this quick video, I wanted to kind of talk to you about what a basic priority queue heap was, show you a couple of pictures for some visual ideas of what a heap looks like in data structure wise on like a picture, and then we're going to create a simple priority queue. So this is going to be the simple priority queue is just like a review over how to make a queue. So we talked about what the heaps were and how they don't exist in Java and how we use priority queue. Now I want to show you a picture. So this, as you can tell, looks probably similar to something like the tree set or binary tree that I showed you last week. When we talked about tree sets, I did mention that they were related to tree sets, but not binary trees. But tree sets were like the library that we use. So heaps also have to do with binary trees. So how they think about it, this is like your visual example of a heap. It looks something like this. And the order saved in the computer goes left to right from your nodes. So what is a node? If you look at every one of these circles over here that contains a number, that is your heap. And so I want you to take a look at how they save these values. I just want you to know in your head how these values work, because I don't want you to get confused in our next video when we start using a little bit more complicated functions and you don't know why. So if we take a look, the first value that we see is 50. Then we see 30, then we see 15, then we see 19, then we see 20, then we see 10, 5, and 2. So essentially, the computer can't save it as a tree. It's going to save it in sort of more of a linear directional thing. And so in order to save it like that, well, you have to find a consistent order. You can't just be like, I'm going to order them however I want, depending how I feel like it. So what the order is it starts from the very topmost node, the parent node, this one that doesn't have anything, that doesn't come from anything. It's just the very tip top. That is the parent node. And it has 2 children, 30 and 15. 30 has 2 more children, 19 and 20. 15 also has 2 more children, 10 and 5. Then 19 has a child, 2. So we go from left to right when we store these in our order. So we start with our topmost node, we go to the left child, then we go to the right, then we go to left child and then find its children. So after we say 15, we don't go down to 10. We go down back to the left node and find its left child. Does that make sense? We go top, left, right, left, so top, left, middle right, right, and then left again. So everything is going in a left to right order. So you might be a little bit confused on why I showed you that, but I just wanted to give you guys a visual example of the heap data structure, because it's important that we're understanding what these are in relation to data structures. And I also wanted you to see the order in which the computer saves it, because that will come in handy next video. So now that we have a pretty good idea of what a heap looks like, I want to show you and want to introduce this concept of minimum maximum heaps. So heaps, we use priority queue mainly to create minimum or maximum priority queue heaps. And so if we take a look at these two visual examples, this is a minimum heap and this is a maximum heap. I want you to pay attention to the way the numbers are listed. Specifically, look at the size of the numbers and where they are in relation to our parent node. In this case, in the minimum heap, our parent node is 10, and this one, it's 100. And you see, slowly as you go down to the children and then down to the children's children, you get bigger and bigger numbers. For this heap, you get smaller and smaller numbers. So this is the concept of minimum and maximum nodes, heaps, sorry. For our minimum heap, the higher up you go node-wise, the smaller the numbers, which means the parent node will always be the smallest number. For maximum heaps, the higher up you go node-wise, the greater the numbers are. So the highest node, the parent node, should be the biggest number out of all your heaps. That doesn't mean your other nodes cannot have the same value. So you can see these are both 50, but you shouldn't really have another number that's greater than 100. You can't have it, otherwise that'll mess up the entire heap. So that was the idea of minimum and maximum nodes. That is something we're going to explore next video, but I think the pictures worked well, so I stuck it into this video. Okay, so I've talked a lot about heaps. I've showed you two pictures, and then I probably confused you. But now let's just go ahead and create our own priority queue heap. And all that is just creating a simple priority queue. So if anybody ever asks you to create a heap in Java, you're going to look at them weird and be like, I'm sorry, that's not possible. But I can create you a priority queue, which also acts like a heap. So this is just a touch up in case we forgot how to create some queues. So let's go ahead and go to REPL it. And then create a new REPL. It's been about a month since we've last created queues. Remember, queues are the ones like the lines that you go when you grocery shop. Everybody's polite and orderly. So the first one in the line is the first one out of the line. So it's just like a regular line at the grocery store, right? I don't know why REPL it is so slow. Let's reload it. There we go. So when I create my queue, there are a couple of things I need to do. One, I need to import my just entire util package. Then I need to, this time, be careful that I'm creating an integer priority queue because we're working basically with a lot of numbers today. So let's go ahead and first import java.util.star. And when I import java.util.star, the next thing I'm going to do is just say priority queue integer PQ heap. The reason why I called it this is because I want you to remember that these are like heaps. So PQ heap is equal to new priority queue integer parentheses semicolon. So we've created our priority queue and we've named it PQ heap. Now we just have to add some values to our PQ heaps. So PQ heap.add, and these are all going to be integers. So there's nothing, and we're just going to put some numbers. So I'm going to start off with some very basic numbers that we're going to be using in our next video. So this will be like a carry on to our next video. Oh, I don't want to order them all like ascending order though. So change this one to 90, this one to 50. Mix the order up a little bit. That's when you know it actually works. And then let's change this one to 5. All right, there we go. So guys, simple, easy. This is just my priority queue. Remember, think of this almost as when you're creating it. This is just like any other queue that we made a month ago, right? So it's just a normal queue. Just next video, we're going to be learning how to, well, basically create the minimum and maximum priority queue. So if I print this out, you see that everything works as normal. It's ordered 5, 10, 50, 90. So keep in mind, this is something that I really want you to remember, especially bring it over to next video. The order has changed. Think in your heart, how did it change? And then we'll talk about it in our next video. So I'll see you guys next video for talking a little bit more about priority queue heaps, and then also about minimum maximum heaps. So I will see you guys then. I hope this video gave you a little bit idea of what a heap was. Bye guys.